Welcome everyone. My name is Amparo Lopez and I am professor at Hydraulic and Environmental Engineering Department in Technical University of Valencia. In this object, we will be speaking about reliability in water distribution system, distinguish between looped and branch network of water distribution. When we finish this object, we will be able to understand the concept of reliability in water distribution system and to learn and identify the different looped and branch water distribution system networks and the influence in reliability in general. So we will be speaking about reliability, branch hydraulic networks, looped hydraulic networks, some design consideration, and finally conclude. So, what is reliability in water distribution networks? The urban water cycle makes that the water comes from a clean source treatment plant to the consumer, and then it goes to some sort of a sewering and then waste treatment plant, and then again to the environmental system. So we have a cycle in which pressure is very important. But in the middle, we have to give the water to the supplied system in a city, to the citizens, with conditions of pressure, flow, and quality ensured in any point. The way in which we give this water without the risk of interruption, without the risk of losing pressure, or losing flow, or losing quality is the reliability of the system, and we must give these conditions to consumer in any moment with the required pressure, head, and flow required. So what happens is that the systems can be doing this in any way, but mainly they do in two ways. One, which is looped systems, given closed loops in which flow can arrive to one consumer by several ways, and one which is the branch in which the flow can arrive to the consumers by one way. So, which is the best? It depends on how we have the system. In any case, we have to give pressure and flow to each consumption point, ensure water quality, economically optimizing the flow and the energy implications. The system can and should be easy maintained, and we have to give a continuing service. When we give all these conditions, we have a reliable water distribution network. How do we do this? We do this by branch, like it's similar to a branch in a tree in which water can arrive to a consumer only by one way, or we can do it in a looped hydraulic network in a very complicated way in which we can use several combinations to arrive to the flow to an intermediate point in the consumption. So, which is the best? Which are the best considerations for a reliable design? We have to give pressure. We cannot have low pressure in any point because we can have pathogen intrusion. We cannot have transient systems. We must give continuum flow in general. To do so, to control pressure and flow, loop systems are very convenient because if we have some sort of failure, we can sectorize the system and give water for other way. In terms of quality, on the other hand, if we have the water moving always directly, we always will have good quality. So in water moving in looping system, we have reduction of the problem associated with water stagnation because we have always a moving. In general, branch system can have a dead end in which water doesn't move in any moment, but it can also happen in loop system. So design will be a combination of loop and branch pipe systems depending very much on the topography, and we can have these problems of interruption, these problems of sectorization, or these problems of quality, and we will combine branch at the end and loop in the middle to be able to serve to always to the community with reliability. In general, densing will be this combination and will depend also on the needs of the particular supply which we will have to be able to design. So we will be distinguishing between branch and loop work system, and we will be considering which are the most convenient in our design in order to ensure pressure, flow and quality in a continuum, optimum and economical manner to make a sustainable water supply system and also reliable along of all the time of operation. I hope this has been interesting for you. Thank you very much indeed.